Imagine pointing one of the most powerful telescopes in human history at the edge of the observable universe and finding something that absolutely should not exist. Not an ordinary galaxy, not a distant star, but a structure so mature, so chemically evolved, so impossibly ancient that it seems to be older than the universe itself. The James Webb Space Telescope has just detected a cosmic anomaly that shatters every model we've built, every equation we've trusted, every assumption we've held about how the universe began. Scientists are scrambling for explanations. Some claim the instruments must be wrong. Others argue that our understanding of the Big Bang is flawed. And a few, the most daring, whisper that this might be evidence of a universe before ours, the fossilized remains of a cosmic cycle that died long before our universe was born. But let's start with the moment everything changed. JWST was observing deep field data from a region corresponding to about 250 million years after the Big Bang, a time when the universe should have been nothing more than small, primitive galaxies struggling to ignite their first stars. Instead, Webb saw something else. A massive, structured, chemically enriched object that looked as if it had already lived through billions of years of cosmic evolution. Stars inside it showed high metallicity. Dust clouds were unusually complex. Entire star clusters appeared fully mature, as if they belonged to a much older era. The kind of structure that should take billions of years to form, appearing in a universe that was barely out of cosmic infancy. It was like seeing a fully constructed skyscraper inside the ruins of a city still being built. It made no sense. Astronomers checked everything: the redshift, the spectral fingerprints, the calibration, the data pipeline. They reanalyzed the infrared curves, cross-referenced old Hubble archives, and compared the readings to theoretical early universe models. Still, nothing explained what Webb was seeing. The structure was real, and it didn't fit. If the Big Bang really happened 13.8 billion years ago, then nothing can be older than the universe. And yet, here we are. JWST has thrown the greatest curveball in modern astronomy, and this discovery forces us to confront a disturbing possibility. The universe may not be as young or as singular as we think. And this structure might be the first crack in the cosmic story we believed for nearly a century.
To understand why this discovery is so devastating, you need to understand what JWST actually measures. When light travels across the universe, the expansion of space-time stretches it, turning visible light into infrared. That stretch, called redshift, is the cosmic clock scientists use to calculate distance and age. So when JWST detects something with a redshift of 12, 13, or 14, we know we're looking back more than 13 billion years, almost to the dawn of time. But the structure Webb found is not just old, it's impossibly mature. Its stars show the presence of heavy elements like iron, magnesium, and silicon, elements forged through multiple generations of stellar life cycles. But here's the problem. At that point in cosmic history, there hasn't been enough time for stars to form, evolve, die, explode, scatter these elements, and then reform into new stars. It's like finding a library full of ancient books in a world where written language hasn't even been invented yet. You simply can't get maturity without time, and in this region of the universe, time did not exist yet on such scales. This forces scientists to consider three radical explanations. The first, our cosmic clock is wrong. Maybe the universe is not 13.8 billion years old. Maybe it's older, much older. If the universe is actually 20, 40, even 100 billion years old, then this discovery fits neatly into a much older timeline. But this requires rewriting almost every major equation in cosmology. The second possibility, the structure came from a universe before ours. The idea of cosmic cycles, universes expanding, collapsing, and rebirthing, is not new, but until now there has been no direct evidence. If this structure is a leftover fossil from a previous universe carried over into ours, then JWST may have just recorded our universe's inheritance from a cosmic ancestor. The third explanation is even stranger. The Big Bang was not the beginning, but a transition, a phase change where our universe inherited matter, energy, or structures from a deeper unknown state of reality. In this scenario, the structure Webb found is a piece of a more ancient cosmos, preserved through that transformation like a scar in space-time. Whatever the truth is, one thing is certain. JWST has discovered something that does not belong. Something that rewrites the timeline. Something that hints at a universe layered with secrets far older than we ever imagined.
But the more astronomers study this structure, the stranger it becomes. Some of its stars appear to have age gradients that make no sense, with outer stars looking ancient and inner stars appearing unexpectedly young. It's as if time inside this object evolved out of order. JWST's infrared instruments also detected unusual energy bursts coming from its core, rhythmic, repeating pulses that do not match the profile of any known star cluster, black hole, or quasar. These pulses form exact mathematical ratios, almost like the structure is ticking in harmony with something outside of our universe. Even more unsettling, the gas clouds surrounding the structure behave in ways that violate early universe physics. They rotate too fast, they hold together too tightly, they contain dust grains that shouldn't exist until billions of years later. In another twist, gravitational lensing around the structure bends light in patterns that appear to originate from behind it, almost as if the structure is partially overlapping with something not from our universe. Some researchers think we may be seeing the shadow of a brain world, another universe layered extremely close to ours, and this structure might sit at the intersection of both. Meanwhile, recordings from JWST show faint background emissions around the structure, a glow too smooth, too uniform, and too ancient to be part of our universe. This glow could be the first direct hint of a pre-Big Bang era, a leftover radiation field from the universe that came before. If this glow is real, then this structure is not just older than the universe, it is a message from before time began. It reveals something else. The early universe may not have been as uniform as we believed. Instead, there may have been pockets, regions where physical constants behave differently, allowing structures to evolve faster, earlier, or outside the normal cosmic timeline. And the structure JWST found might be the most extreme example of such a pocket, a cosmic glitch where evolution occurred at impossible speed. Whatever this is, it forces cosmologists to admit something once unthinkable. The universe may not be one clean, linear story. It might be a tapestry of overlapping eras, tangled timelines, cyclic echoes, and ancient remnants woven into the fabric of our reality. Webb is not just looking back in time, it is catching the fingerprints of universes stacked on top of ours.
So what does this discovery mean for us? Right now, every major cosmology team on Earth is debating the same question. If this structure is confirmed to be older than the universe, then the entire foundation of modern cosmology must be re-examined. It means the Big Bang is not the single beginning we believed. It means time itself did not start at zero. And it means the universe may carry memories, relics from epochs long before ours. Some scientists propose that our universe rebounds from previous cycles, each one leaving behind traces in the next. In this view, the structure JWST detected is a survivor, a cosmic fossil that endured the collapse of the previous universe. Others suggest that the early universe was far more complex than we imagined, with periods of accelerated evolution, exotic physics, or variable time flow. In that case, this structure might not be older than the universe, but created in an environment where time moved differently, allowing billions of years of evolution to occur in a fraction of cosmic history. There's also the possibility of multiversal overlap, two universes brushing against each other. If that's true, then JWST may have captured the first observational evidence of the multiverse, a structure birthed elsewhere, slipping into our cosmic horizon. As JWST continues scanning, more anomalies appear. Galaxies too massive, stars too old, dust too heavy for their supposed time period. The deeper we look, the more the universe breaks its own rules. And this discovery, this impossible structure, may be the key to understanding why. It suggests that the universe is not a simple, isolated bubble of space and time. It is part of something larger, a cosmic ecosystem of births, deaths, collapses, and rebirths. A universe with a lineage, a universe with history before our history. If the structure is truly older than the universe, then humanity has just glimpsed the greatest secret hidden in the cosmos, that our universe is not the first, not the only, and not the oldest. It is merely the latest chapter in an endless cosmic cycle. And the James Webb Space Telescope, with its golden mirrors and relentless vision, may have just opened the first page of a story far older than time itself. The story of what came before the universe, and what might come after